day, student, this is code here. The topic I have today is integration. In the last episode, I taught differentiation, and I proceeded to application of differentiation. But today, I'm taking you into integration. Integration can also be seen as anti-differentiation. It's like opposite of differentiation. When you have a function, it's like the opposite of that function is integration. Let me first of all show you something. Let me start from the perspective of differentiation. In this, I have y is equal to al squared, ax raised to power n. You know, a is the coefficient, n is the power. Now the y dx is I multiply this one and this one, then I take one away from this one, then I have an x n raised to power minus 1. This is differentiation. Now integration. In integration, I have dy dx, which is an x n raised to power minus 1. You know, this is the result I have when I differentiate. Now I want to integrate this function. For me to integrate, I will first of all add 1 to the power. Then I will use the result I have. I will divide everything with the result. Now look at this. I have y now is equal to an x n minus 1. All this one is equal to this. Then plus this one. Now this is the new power I have here. So n minus 1 plus 1 is, I use this one to divide the function, then plus c. Now I have an x n all over n. No, minus 1 plus 1 is equal to 0. Minus 1 plus 1 is equal to 0. Therefore I have an x raised to power n. Then this n cancels the n. I have ax raised to power n plus c. Now this one is the integration of this function. Now I have this one. Why do we have constant when we integrate? Why do we have constant? This constant is very vital, and in some cases constant is optional, but in some questions constant is very vital. Look at all the examples I put on the board. Y is equal to 2l squared, y is equal to 2l squared minus 4, y is equal to 2l squared plus 10. You know, all these functions, they are not the same thing. But if I find the y dx of this one, I get 4x. The y dx of I get 4x. The y dx of this one, I get 4x. Then if I integrate all this one, I should get this one. In this place, when the y dx go to 4x, if I integrate, I get 2l squared plus c. For this one, in this case, my c is equal to 0 when I have 2x raised to power 2. Then my c is equal to minus 4. If I have y is equal to minus 2l squared minus 4, my c is equal to 10. In this case, if I have y is equal to 2l squared plus 10. Now, if you want to find an integration of a function, find the function of which the gradient function is 5x raised to power 4. In this place, based on what I said when I was explaining how to use the formula, this one is the coefficient, this is the power, this 4 is the power. Now, by the time we added 1 to this one, we have 5. Then we divide everything by 5. So we have 4 plus 1, then over 4 plus 1. So now we have 5x raised to power 5 all over 5. Then 5 divided by 5, x raised to power 5 plus c. So this one is the integration of this function. This is another example. If f, this one means the y dx, f prime x, that is, when you differentiate f of x, this is what you have. So this dy dx is equal to 3x raised to power 5. Find f of x. That is the equation of this function. Now this one is the gradient. Then this one, to find the equation of that function. Now, when f of x, f prime of x is equal to 3x raised to power 5, I added 1 to 5, then I have 6. 5 plus 1, I use 6 to divide this function, then I have 3 here 1, 3 here 2, I have x raised to power 6 all over 2 plus c. This is another example. In this place, I have dy dx is equal to minus 2 all over x raised to power 3. Now, in this case, when I add this function, you know, I can try to rewrite this. No, this one is what to this one. I can change, you know, I have this one. This is the numerator, this is the denominator. Now I can have minus 2 x raised to power minus 3. Because this one is initially it was the denominator. Now I have minus 2 x raised to power minus 3. And in this case, you will be very careful when you are added to, you know, this will be minus 3 plus 1. Which will be equal to minus 2. Therefore, I have minus 2 x raised to minus 2 all over minus 2. So that minus 2 here, cancel minus 2, you have x raised to minus 2 plus c. Or I can write it as this, 1 over l squared plus c. This is another example. In this example, I have integral of x raised to power 3 all over 2 plus x raised to power x square all over 3 plus x all over 4 plus 1 over 5 dx. In this place, I'm using the normal procedure I said earlier on. This first one, 3 plus 1, this one 2 plus 1, the next one 1 plus 1. Then you know that when I have any constant, because I integrate with respect to x, so it means that my 1, anything raised to power 0 is equal to 1. So it means that 1 is x raised to power 0, then plus 1. Now I have x4a, I have x3, x2, then x all over. Initially I have 2 as the denominator here. So I have 2, then multiply by that 4. Then 3 multiplied by 3, 4 multiplied by 2, 5 multiplied by 1. Then I have this as my solution, x raised to power 4 all over 8, x raised to power 3 all over 9, x raised to power 2 all over 8 plus x raised to power x over 5 plus c. This is another example. In this place I have square root. And I said something when I was teaching differentiation, that the sound knowledge of indices is very vital when we are doing differentiation, when we are doing integration. In indices, when you have root of anything, it means that function raised to power half, if it is cubed root raised to power 1 over 3, root 4, root 5, and so on and so forth. In this case, I have integral of root x dx. Now, so this one means x raised to power half dx. Now, when I have the coefficient of this one, the power is half. So half, which is the power plus 1, all over half plus 1 again. Then I have x raised to power 3 over 2, all over 3 over 2. When you have x raised to power 3 over 2, all over 3 all over 2, it means 2x raised to power 3 over 2 all over 3. It's as if you have x raised to power 3 over 2 divided by 3 over 2. So it's going to be multiplied by 2 over 3. Then we have 2x raised to power 3 over 2 all over 3 plus c. That's the final answer for that one. Now this is another one. Integral of 1 all over 3 cube root of x squared. Before you can solve for this question, you need to rewrite it in another form. Then this one is equal to 1 all over 3x raised to power 2 over 3. Then I can write it again. 1 over 3 here is the coefficient of this function. 1 over 3 is the coefficient. Now, so I take 1 over 3 out. You can have it inside here. It spoils nothing. But here I have 1 over 3 here. Then I have x raised to power minus 2 over 3, which is the power we have now, as the power that I'm dealing with. So minus 2 over 3 plus 1 all over minus 2 all over 3 plus 1. Then I will have x 1 over 3 all over 1 over 3, which is equal to 1 over 3 in bracket 3x raised to power 1 over 3 plus c. Then if I solve this one, these 3, we cancel these 3, because 1 over 3 multiplied by 3 is equal to 1. Therefore I have x raised to power 1 over 3 plus c. And I can write it as this: cube root of x plus c. X raised to power 1 over 3 is cube root of x. Cube root of x plus c. Now I want to talk about two types of integral. We are doing integration. I know that you must have been watching me as I'm talking about integral. Now, what two types of integral? We have definite integral and indefinite integral. Indefinite integral, you see this integral sign has a value here and here, upper value and lower value. But if it is indefinite, you don't have anything up and down. You just have this as plain. Now, if you have definite integral, it means that you get definite answer. In indefinite integral, you get definite answer like something like 2x plus 5, 3x squared plus 5, or plus anything plus c. In definite integral, when you are substituting for the upper one, lower one, you have c up, c down. So again, you have c minus c. So in definite integral, you don't need to bother yourself about constant c, because as we get definite answer, you know that constant c will be crossed out of your calculation. So you don't bother yourself about the constant c's when you are dealing with definite integral. Example. In this is an example of indefinite integral. Integral of minus 5 over x squared plus 6 over x cubed plus 6 over x4 dx. So this one is equal to minus 5 x raised to power minus 2 minus x 6x raised to power minus 3 plus 6x raised to power minus 4. Now if I add 1 to all the power, the first one will be minus 2 plus 1, the second one minus 3 plus 1, the second one minus 4 plus 1, all divided accordingly, divided by the new powers. The new powers are divided by the new powers. Then I have minus 5x over minus 1 all over minus 1 minus 6x squared all over minus 2 plus 6x raised to power minus 3 all over minus 3 plus c. By the time I have this one, by the time I divide, I have 5x raised to power minus 1 plus 3x raised to power minus 2 minus 2x raised to power minus 3 plus c. This answer is okay, or I can write it like this. This one raised to power negative, raised to the negative power, so I can have 5 over x plus 3 over x squared minus 3 over x cubed plus c. This one is an example of definite integral. You can see here I have 2 as the upper boundary. I have 2 and 0. Now, having integrated this one, normal way of integration, by the time I want to integrate this one, I will have 6x 2 plus 1 all over 3. Then 2x, I have 1 before plus 1, 2 all over 2 minus 5x. I don't have any coefficient for this 5, so I have 5x. Now we have this angular bracket. By the time you have this bracket, then you have 2. This 2 is up here and 0 is down here. So it means that you have started the integration. Now what you do at this level, like you pick these 2. Everywhere you have x here, put 2 to represent, minus you put 0 inside. So when you put 2 inside, you get this. 2x cube, you change the 2 bracket 2 cube plus 2 square, x square 2 square minus 5x, which is 5 bracket 2. This is for 2. Then minus, I put 0 inside. Actually, I know that this 0 will be equivalent to 0. So at the end of the day, if you solve all this one, I have 0. So this value minus 0 is equal to 10. So the answer for this integral, the answer is 10. We have definite answer here, unlike the indefinite integral when I have something like something x plus something. Now this is the second example. I have this another example. This also is another example of indefinite integral. So in this place, if I integrate this, I have 10x all over 4 minus 9x cubed all over 3 minus 8x squared all over 2 plus x plus c. Then if I break it down, I have this as my final answer. Now this is another example of definite integral. Here I have 1 and minus 2. And I want to say something here. Anytime you are dealing with definite integral, what you have up here must be greater than what you have here. It's not going to have minus 2 and 1 here. Now we have 1 and minus 2 here. Then I've integrated, I have this one, I have 1, I have minus 2. Then in this place, I have 3x squared plus 2x, I have 1 here, I have minus 2 here. Then this place, I substituted the 1 inside this place. You have another bracket here, minus, then I substituted minus 2 inside this place. Whenever you are substituting negative value, be very careful so that try to work with the negative so that negative doesn't nullify the correct answer. So at the end I have 3 plus 2 minus 12 minus 4, which is equal to 8, then 5 minus 8. So the answer for this one is minus 3. The summary. Now I've talked about introduction to integration, and I started by showing you the relationship between differentiation and integration. In differentiation, when you differentiate a function, integration means like you are taking the equation you have differentiated back to the normal equation. Now in integration is anti-differentiation. I said about that one, and I also mentioned about types of integration. I talk about definite integral and indefinite integral. In indefinite integral, you get definite answer, and it asks when you have that integral sign, you have a value up and a value down. And I told you that the value you have up is greater than the value you have down. Now by the time you find integration, by definite integration, you get definite answer, and in indefinite integral you get indefinite answer, not a specific answer. Now I want you to lay your hand on these assessment questions. I have 4 questions. The first question says f of x, that is the y ds. That when you have f prime means that this function is a differentiated function, is a gradient, is equal to minus 3 over x4, minus 3 all over x raised to power 4. Then find f of x, that is the equation of this gradient. Now the second one, find the function whose gradient is 6x squared minus 2x plus 1. Then the third one, evaluate this function, integral of x squared minus 1 over x squared dx. Then evaluate integral of integral 1 0 18x squared minus 12x plus 3. And don't forget, I said something about definite and indefinite. If you look at all these questions, number 1 is indefinite, number 2 is indefinite, number 3 is indefinite, it's only number 4 that is definite. So in this number 4, I want to get a definite answer. I know that by the time you lay your hand upon this question, you will get it, and every other question you can you can find in any textbook. With all these things I've said earlier on, if you try to put them into practice, you will be happy that every question you face to do, you will get them and you'll be happy. Thank you very much for taking part in this episode, and I know that you have understood this thing and you need to practice more and more so that you become perfect in it. Thank you very much. Happy viewing.